Our current way of thinking about the evaluation of programs relies on substitution, and substitution relies on identifiers having fixed values. For example, if we have a program that binds x to 5 and has a function that refers to x, and that function is called later, we can substitute 5 in place of x and get the same program out. There's no way for the x to have meant anything different somehow between the time that f is bound and the time that f is called. In PLAI typed, that's actually not true. A variable's value can change. Here we have the same sort of program, but I filled in the dot dot dots with a setbang x6. And setbang is an assignment operator. This is like x equals 6 in many other programming languages. It changes x so that its value is 6 instead of 5. So that when f is called, since it refers to x and x is changed, we will get a 7 out. We would say then that variables have state, because a variable has a particular value at a particular time. That's the state of the variable. This kind of program is not the kind of program you should generally write in PLAI typed. Assignment to variables is generally discouraged. But in other languages, of course, it's quite common. For example, suppose that you're writing a program in Java to sum a list of integers. You'd probably write it like this. You would iterate over the list, but the assignment part is that you would have some variable like t that you would update on each iteration and then finally return the value of t. In PLAI typed, we would write sum this way, just as a recursive function that has empty and cons cases and adds the first to the sum of the rest. If you think about it, these two programs are actually different, because here we sum the rest to the right and then add on the number on the left, whereas this iteration is adding from left to right. So if we want to get exactly the same program, then we would write it this way. We would need to accumulate this current total t, start out at 0, and every time we go down the list, we add on the first one to the total so far, returning the accumulator in the empty case. So these two programs are actually equivalent, and a good compiler will produce essentially the same machine code. But they're using different language features. This one is relying on assignment to a variable. This one is effectively creating a new variable on every iteration. A new t gets the value of the old t plus some element of the list. Of course, you could also write sum in PLAI typed this way using foldal, which is just a kind of pattern like for that encapsulates the iteration and the combination, just even a more specific one than for. In other words, the state that you might use in this kind of program is not really an essential use of state. It's something you could write in a different way. Here's another example with a different kind of state. In this case, if you imagine representing an aquarium as a set of fish, which integer weights, and you want to feed all the fish, you might represent that aquarium with an array in Java and increment each element of the array to feed the fish. Whereas in PLAI typed, we might use a list or a vector, but when we feed them, most likely we'd use a list and return a brand new list as a result. So again, we wouldn't change the list. This is different from state on variables. It's state on an array. And these programs are not the same. Right? They're different kinds of programs. And still it's inessential in that you don't have to have state to implement the function feeding fish and represent fed fish. In fact, avoiding state, doing it the functional way, has some advantages. Testing is easier because you can just check the result of feed matches some expected list, and you don't have to worry about testing exactly how some value got passed in, value that was passed in was changed. Right? And also it's a little more general in that maybe you want to feed the fish and then compare the old value, the old fish to the new fish, then you still have the old one around. You don't have to think hard about in what ways feed might change your today list. On the other hand, there are other problems where state is really essential to implementing it, often because of the toolbox that you're working with. And here's an example of a GUI where 7 is meant to be the fish's current weight. We can feed it 1 or feed it 3 by clicking the buttons. This number will increment by 1 or 3. And so the state of this GUI is the weight of the fish. And with many GUI toolkits, that state will have to be implemented using state as well at the programming language. And that's because GUI toolkits often have something like makeButton. We provide a function that is called when the button is clicked. That function might receive something like a representation of the click event, but it doesn't receive a value corresponding to the state of the program. Instead, you would have to set that state as a side effect inside the callback function, and maybe also update in a stateful way the display. And the reason here, you can't do this by sort of passing around the current value, the current weight of the fish, because the make button API doesn't let you do that. So what that example illustrates is that state gives you an extra way of communicating between different parts of a program. It allows a function call like f of 1 to affect some future call g of 2 even though nothing in g of 2 points directly back to the result of this function. Right? In other words, it's a side channel. By f changing some state and g consulting that state later, it provides a side channel of communication from different parts of a program. And that in general is what state lets you do. So the good part of that is that with whatever API you're working with or whatever existing functions, you can add your own channel of communication among different parts of your program whenever you need to. Right? That cuts the other way, that when someone is reading a program that uses state, they may not be aware of all the channels of communication that are hiding behind function calls. And that is often what makes bugs difficult to replicate or to understand, because it's hard to figure out what is changing in the background as you do various things. So there are good points and there are bad points to state, but clearly it's a significant feature of programming language and something that we should study.